Hello dear students and welcome back to the class. So as I promised you that after completing the theory part we are going to start with the questionnaire round. So here are the questions for the NEET pattern from the chapter atoms. So let's start with the question number 1 without wasting much of our time. So the question number 1 says that a small particle of mass m moves in such a way that the potential energy U is given to us, where omega is a constant and r is the distance of the particle from the origin. Assuming the Bohr's model of quantization of angular momentum, we have to calculate the radius of allowed orbit. So basically what we have to calculate? We have to calculate the radius. Okay. So to start with that, I think we should first of all consider the one thing that has been given to us, which is U, that means the potential energy. So potential energy U is given us to be half m square omega square into r square, right? So as you know that if we define the conservative force, we know that a conservative force is the derivative of the potential energy. So I can write the conservative force as Fc equals to minus du by dr. So if I will be solving it, I will be getting du by dr of half m square omega square into r square, and so finally I will be getting half as common, m square omega square is common, r square, the derivative of r square will be 2r. So I got m square omega square into r, this is the derivative du by dr. And as you know, this is the conservative force. To rotate in a circular orbit, there will be a centripetal force which will be required. The centripetal force must be equal to this force so that it can rotate in a circular orbit. So to make it equal, I will be writing centripetal force. Let me just write the centripetal force as small fc equals to capital Fc, which is the conservative force. So you know that centripetal force is written as mv square upon r. mv square, v is the velocity, r is the radius, and it will be equals to m square omega square into r. So from here I will be getting the value of v, or even I will be getting the value of r. M and m will be getting cancelled. I got v square equals to m omega square into r square. This I got. Now what I have to do, I have to find the radius of nth orbit. To find out the radius, I can see the velocity can be written as, because from here mv square by r equals to m square omega square into r. Now r square equals to v square. Okay, so from here if I will be able to find out v square is m omega square r square. Okay, so from here if I will be finding out the value of r, it will be come out to be equals to v square upon m omega square under root. This is the value of v. But since I know I have to use the Bohr's model of quantization of angular momentum, I know that this angular momentum condition is L equals to mvr, or you can directly write mvr equals to nh upon 2 pi. Everybody knows this is the Bohr's quantization condition of angular momentum. So from here what I will do, I will be finding out the value of v, and I will be putting this value of v in this equation so that I can get the value of r in the terms of n. So from here v is equals to nh upon 2 pi into m into r, right? Now put this value, say this is equation 1, this is equation 2. Now put this 2 into 1, putting 2 into 1, I will get r equals to under root of v square. So v square will be n square h square upon 4 pi square m square into r square into m omega square, right? This I got the relation of r with n. Now see over here, here it is n r also. So what I am gonna do, I will be taking this r to the left hand side so that I will be having r square equals to under root n square h square divided by 4 pi square into m square into This r square, if I'll be taking under root r square, that will become r. This r will go to this side and it will become r square. So I have directly written r square, and this will be m cube omega square. Since I have to compare the value of r with n, so what I have got a relation r square is proportional to under root n square, isn't it? So from here you see that r square is proportional to under root n square, but what we want to get? We want to get the value of r. So r will be proportional to under root n square raised to the power 1 by 2. So from here we got r is proportional to n square, right? So now we have to correlate this answer with the given option whether this is the correct or not. So I got r is proportional to n square. So yes, I can see option number A is the correct answer for the given question. Okay. So now let's just move to the next question. Okay, so question number 2 says, which of the following electron transition in hydrogen atom will require largest amount of energy? See, you just have to understand when will you be required the amount of energy and when will the atom will lose energy. You already know that when the transition is taking from higher energy level to the lower energy level, in that case energy is going to be transmitted. But if you want the electron to be jumped from lower energy level to the higher energy level, in that case the energy is going to be absorbed. And also in all these cases you can see over here, electron is going from a lower energy level to a higher energy level, from n equals to 1 to 2. To going from lower to higher electronic shell, electron will be required the amount of energy, and that is what we have to find out here. So we have been given the shells where the electron is jumping, but I must tell you, see, this is the nucleus, these are the shells. Okay, suppose this is n equals to 1, n equals to 2, n equals to 3, and moreover we have been given n equals to infinity as well in the question. You have to understand one thing over here. If the electron is present in this shell, in this shell, in this shell, which electron will be required the largest amount of energy to be released from this position? Since you know that this electron, which is a negative charge particle, is bounded with the positive nuclei, it will be bounded with the higher energy. So this electron which is binded with the higher energy will be required the highest amount of energy to be emitted out. So that is why we can say that highest amount of energy will be taken in the case when the electron will be taking transition from n equals to 1 to n equals to 2, right? Moreover, you can see from this formula, we have this formula E equals to minus 13.6 upon n square. So as the number of shells is going to be increased, energy is going to be decreased. As the number of orbit is going to be decreased, energy is going to be increased. So here, since the transition is taking from n equals to 1 to 2, 2 to 3, 3 to 5 and infinity to 1. So in all these cases I can see the energy, the maximum energy will be required for this case, because in this case the electron is tightly bound with the nuclei. And moreover, I can, if I'll be correlating with this option with this formula, I can say that this must be the correct option for this particular question. I have given you the logic of this question. Now let's begin and just move to the next question of this session. Question number 3 says, electron in the hydrogen atom first jump from the third excited state to the second excited state, and then from the second excited state to the first excited state. The ratio of the wavelength lambda 1 to lambda 2 emitted in the two cases is what? That's what we have to find over here. But let me just tell you, first of all, you should know what do we mean by the first excited state, second excited state, and then again second to first, okay, third excited state. See, you know that this n equals to 1 is called as ground state, right? So n equals to 2 must be the first excited state, and n equals to 3 is the second excited state, n equals to 4 is the third excited state. Okay. Now since the question is given in the form like electron in hydrogen atom first jump from third excited state to the second. So from third to second, this is the third excited state, it is coming into the second excited state, which is this. In this case, the wavelength lambda 1 is released, and when the electron is taking transition from second excited to the first excited. Now this is the second excited state and this is the first excited state. When the electron is jumping from this to this level, lambda 2 is getting released, and we have to find out the ratio lambda 1 is to lambda 2. Now we are going to solve this question. We know that in the first case, if I will be writing in the terms of energy, we know that E equals to Z square RHC 1 upon NF square minus 1 upon Ni square, and here NF is the final energy level and Ni is the initial energy level. E can be written as Hc upon lambda. Now in the first case, when we are taking the lambda 1, so in this case NF is what? Energy is electron is taking transition from initial level 4 to initial level 3. So NF is 3 and Ni is 4. So NF is 3, so square of 3 minus Ni square, which is 4. So see over here, Hc cancelled. Since we are talking about the hydrogen atom, we are given in the question that we are talking about the hydrogen atom. So we are going to take Z equals to 1. Okay. So we are now left with 1 by lambda 1 equals to R 1 upon 9 minus 1 upon 16. So you will be having 7R by 144. Okay. Now in the second case, let us just take in place of lambda 2, I will be having RHC 1 upon NF square. Now N is what? In the second case, transition is taking from initial level 3 to final level 2. So initial is 3, final is 2. So final is square of 2 minus initial is square of 3. Okay. So Hc cancelled. You are left with 1 upon lambda 2 equals to R 1 by 4 minus 1 by 9 equals to R. This is 5R upon 36. This is 1 by lambda 2. Now since we have to take the ratio, that means lambda 1 upon lambda 2. In the question we have been given that we have to find out lambda 1 is to lambda 2. So it can be find out using 5R upon 36 into 144 upon 7R. So when you are going to solve it, you will see that answer will come out to be 20 upon 7. Okay. So this is the option, and we have to check from the option. 20 by 7 must be the correct answer for the given question, right? This was the approach of starting the question, and I have tell you which formula you should apply to get this answer. Now let's just move to the next question, question number 4. Question number 4 says that an electron of a stationary hydrogen atom passes from the 5th energy level to the ground level. 5th energy level to the ground level. The velocity that the atom acquired as a result of photon emission will be what? So we have to basically find out the velocity over here. So we have to find out the V. In this case, electron is taking transition from hydrogen atom, passes from 5th energy level to the ground level. So that means NF equals to 1 and I equals to 5. So basically to find out the velocity, what I can do, I will be first of all finding out the energy. Because energy can be written as Hc upon lambda equals to Z square RHC 1 upon NF square minus 1 upon Ni square, isn't it? If I'll be using it, I will be having Hc upon lambda. Hc will get cancelled, so I'll be having 1 by lambda. 1 by lambda equals to Z square. Since again I am talking about the hydrogen atom, so I'll be taking the Z equals to 1. So Z will be taken as 1. So Z's are 1 upon Nf square. Now Nf is 1 minus 1 upon Ni square, which is square of 5, that will be 25. So you will be having 1 by lambda equals to 25 minus 1, so that will be 24R upon 25. This is your wavelength. Since I have to find out the velocity, I can now think over one thing, which is the de Broglie wavelength and the de Broglie relation, which says that lambda equals to h upon p, or you can write the momentum in terms of mass and velocity like h upon mv. So if I have to find out this velocity, can I use this formula to find out the 1 by lambda? And 1 by lambda will be equals to mv upon h. So what I am going to use, I will be using in place of 1 by lambda as mv upon h. So if I will be putting mv upon h equals to 24R upon 25, I have to find out the value of v. So v will come out to be equals to 24R into h upon 25 m. This is my velocity. And now I have to verify from the given option that 24RH upon 25m is the correct answer or not. 24RH upon 25m, option A seems to be the correct answer from the given option. Okay. So basically you have to start with the equation and you have to apply the de Broglie wavelength relation in this question. Okay. Questions are not so tough, but you just have to think over one thing, that what should be the approach of question. Question number 5 says, according to Bohr's theory of hydrogen atom for the electron in the nth orbit, the linear momentum is proportional to 1 by n, radius is proportional to n, kinetic energy is proportional to 1 by n square, or both A and C are correct. So to begin with this question, you should know the formula of the Bohr's atomic model, the radius of allowed orbit, the kinetic energy, the velocity, the frequency, all these things. So if I talk about the radius of nth orbit, is it visible to you? I think I should write it. N square h square divided by 4 pi square Zm ke square. This is the formula for the radius of allowed orbit. Now if I write about the velocity, it is 2 pi ke square by nh. And if I talk about the frequency, it is kze square divided by nh into r. And if I talk about the kinetic energy, it is directly energy I am writing minus E square upon 8 pi epsilon naught into r. These are the formulas that you can cram up. I can basically say you can cram up these formulas, because these are very important formulas from this chapter, because the question directly comes from these particular formulas. And these are the formulas from the Bohr's atomic model. Okay, so in this question, we have been given that linear momentum is proportional to 1 by n. Linear momentum can be written as P equals to mass into velocity. Now since velocity is proportional to 1 by n, or you can say V, that means velocity is inversely proportional to n. So can you say that momentum will be also proportional to 1 by n, right? Since P is proportional to V, V is proportional to 1 by n, so P will also be proportional to 1 by n. So the option number A is correct according to us. In the question B part, because I can see that in the option D both A and C are given. So I have to verify B also and C also, whether maybe these are correct or not. So to check the radius, radius is proportional to n. But in the option, in the formula I have clearly written, we know that radius is proportional to n square but not n. So that means this option is wrong. Now the C option, the kinetic energy is proportional to 1 by n square. In this formula, I have written the energy only in terms of R. But we know that kinetic energy is equals to half mv square, right? And we can see that V is proportional to 1 by n, or you can say V is inversely proportional to n. So, since V is inversely proportional to n, or you can say V square will be inversely proportional to n square, right? So, that means kinetic energy will be also proportional to 1 by n square, right? Clear? So, now let us check what is given. Kinetic energy is proportional to 1 by n square. That means this is also correct. It means from all these options, option number D must be the correct answer, because both A and C are correct according to us. So, you do not have to take over 1 and C option, over A and C, you just have to correct tick mark over D option. That means both A and C are correct. Okay. Now, let us just move to the next question. The question number 6 says that an electron is in an excited state in a hydrogen atom. It has a total energy of minus 3.4 electron volt. The kinetic energy of the electron is E. What is its de Broglie wavelength? Understand the question, try to understand the question. We have to find out the de Broglie wavelength. We have been given the total energy. It has a total energy of minus 3.4 electron volt. But since I have to find out the wavelength, I know there is a relation between wavelength and energy, which is lambda equals to h upon under root 2m into E. And this E is nothing but the kinetic energy. So, I can write Ek, that means kinetic energy. So, to find out this, I need the kinetic energy, I do not need the total energy. We know that total energy can be written as kinetic energy plus potential energy. What I have to do? I have to find out the kinetic energy. We know that there is a relation between kinetic energy and potential energy, which is that this potential energy is twice of kinetic energy. But what do I have? I have only the total energy. So, basically from here I have to first of all find out the kinetic energy. So, what I will do, I will be writing in place of potential energy as minus 2 into kinetic energy, right. From here what I get? I got minus kinetic energy. This is a relation, a very important relation, which you should not forget, that potential energy is equals to minus 2 times of kinetic energy. And using this, we have got this total energy is coming out to be equals to negative of kinetic energy. That means kinetic energy is equals to 3.4 electron volt, right. Now, since I have to find out the de Broglie wavelength, so lambda equals to h upon under root 2 into m into E. Now, since it is given in the electron volt, I have to first of all convert this into joule. Now, to convert this into joule, I have to multiply it with 1.6 into 10 raised to the power minus 19 joule. Okay. This has been now converted into joule. Now, put this value into this equation. I should directly put this value. So, we will be having lambda equals to h. H is the Planck's constant and value of Planck's constant is this, upon 2 into m. Now, see, we have to put the value of m, the kinetic energy of electron. We are basically talking about electron. So, if we are talking about electron, I can put the mass of electron, which is 9.1 into 10 raised to the power minus 31 into this particular value, that means the energy, into 1.6 into 10 raised to the power minus 19. After solving it, you will see that lambda will come out to be equals to around 6.6 into 10 raised to the power minus 10 meter. You can use your calculators to calculate and find out the value. You will see that this value will come out to be in the range of this. So, let us just verify 6.6 into 10 raised to the power minus 10. Option A It seems to be the correct answer for the given question. Okay. Now let's just move to the next question. I hope this question is understood to you. You can see all these options have small tricks which you can remember and you can use in your exam time. Question number 7 says, in the Rutherford's alpha particle scattering experiment with thin gold foil, 8100 scintillations per minute are observed at an angle of 60 degree. The number of scintillation per minute at an angle of 120 degree will we have to find out. So there is a formula. How can we find out the number of scintillations, which is n is proportional to cot raised to the power 4 theta by 2, and there n is the number of scintillation, theta is the angle. So since we have been given, first of all, n1 equals to 8100, theta as 60 degree. So n1 is 8100, theta 1 is 60 degree, and we have to find out n2. We have been given theta 2 as 120 degree. 120 degree. So I can use the above formula to find out the n2 easily. You just have to remember this formula if you have been given the number of scintillations to be find out. So n1 upon n2 will be equals to cot raised to the power 4 theta 1 by 2 divided by theta 2 by 2, right. Now cot theta 1 is 60, so cot 60 is 1 by root 3, and the square, sorry, cot 4 theta will be equals to 1 upon 9, right, and cot theta by 2, that means cot 120 degree, yeah, cot 120 degree, because theta is 120 degree, and also we have to find out the cot theta by 2, which will be root 3. At 120 degree, value will be root 3. So from here, your theta cot 4 theta will be equals to 9. So if I will be putting the value, n1 is 8100, n2 is unknown to us, we have to find out. Cot 4 theta 1 by 2. Okay. So I did a petty mistake over here, that I have to find out first of all theta 1 by 2, and this all we have to make a change over here, because I have just used the value of theta and not used the theta 1 by 2. So theta 1 is 60 degree, theta by 2 will be equals to 30 degree. Now cot 30 will be equals to 1 by root 3, and cot 4 theta will be equals to 9. Similarly, theta 2 is 120 degree, theta 2 by 2 will be equals to 60 degree, and cot 4 theta, cot 60 degree is equals to 1 by root 3, and cot 460 degree will be equals to 1 by 9. Okay. Now these are the values that I am going to use. Cot 4 theta 1 by 2, which is 9, and cot 4 theta 2 by 2, 1 by 9. So it will become 81. So that means from here n2 will come out to be 8100 upon 81. So your number of scintillation in the second case will be 100, and we have to verify from the given option whether, yeah, from the option number A, this is the correct answer for the given question. Okay. So formula is this, you have to remember, and don't just make a mistake like I did right now. So make a correction and do this change. Okay. Now let's just move to the question 8. When the hydrogen atom emits a photon in going from n equals to 5 to n equals to 1 state, its recoil speed is what? We have to find out the recoil speed. Electron is taking transition from 5 to 1. So initial is 5, final is 1. Okay. Recoil speed we have to find out. Again we can use one formula, which is hc upon lambda equals to z square rc RHC 1 upon NF square minus 1 upon Ni square. Or you can directly use the value like 13.6, because again we are talking about the hydrogen atom, so we directly can use 13.6 in place of this particular value. So we will be having Hc upon lambda equals to 13.6 1 upon Nf square, which is 1, minus 1 upon Ni square, which is 25. So 13.6 into 24 upon 25 will come out to be 13.025. Okay. Now what we have to do? We have to find out the velocity. So to find out the velocity, I know that lambda equals to h upon mv, right? Since I have to find out the velocity, I can use this h upon m into lambda, right? I got the value of lambda, hc upon lambda as 13.025, right? So what I can do, I can use this hc upon lambda, or I can directly use 1 upon lambda will be equals to 13.025 divided by hc. Okay. Now since I am having h upon m lambda, okay, I can do one thing, I can use, from here I can find out the value of 1 by lambda. It will come out to be 1 by lambda will be equals to Vm upon h, right? So Vm upon h equals to 13.025 upon hc, h into c. Since we are having h, we will cancel it out and we will be left with V equals to 13.025 upon m into c. We have to find out the V. So you can do one thing to find out the V. It will be equals to 13.025 divided by mass. Now see what mass we are going to use. In the question we have been given the photon. So basically we are talking about photon. So photon, mass of photon is equivalent to mass of proton. So we can write 1.67 into 10 raised to the power minus 27 into c, which is speed of light. So solve it out. I think this value should be come out in the range of 4 meter per second. So let's just check and verify. Option number C is the correct answer for the question. Okay, you have to use the calculator to just make a correction, not a correction but to check the calculation. Let's just see question number 9. The frequency of the first line of Balmer series in the hydrogen atom is nu naught hertz, and the frequency nu of the line emitted by a single ionized helium atom is, that what we have to find. So frequency of first line of Balmer series. If we are talking about Balmer series, in that case we know that the final energy level is always 2, and if we are talking about the first line, that means initial level should be equals to 3. That means the electron should be coming from 3 to 2. And in case if in the question we have been given the last line in place of first line, so you will be using the initial level as infinity. Okay, that is the thing which you have to keep in your mind. So Nf equals to 2, Ni equals to 3. First of all, what we have to find out, we have been given the frequency. So h nu naught equals to z square r at c 1 upon Nf square minus 1 upon Ni square. Since we have been given the frequency, I will be using the frequency only. Otherwise, I will be using hc by lambda because this is only the energy. So h cancelled. Firstly, we were talking about the Balmer series in hydrogen atom. So we are going to take z equals to 1. Okay. So over here, nu naught will be equals to rc 1 upon Nf square. Now Nf is 1 by 4 minus 1 upon 9. So 9 minus 4, that is 5 upon 36. Is it correct? 5 by 36. So we got nu naught equals to 5 rc upon 36. Let's just do one thing. In the another term, we have been given the case of helium atom. So we know that for the helium, For the helium, Z equals to 2, right? So what we are going to use? We are going to use the same formula, which is H into, now we have to find out the frequency nu. So I will be using nu over here. So H nu will be equals to Z square RHC 1 upon NF square minus 1 upon Ni square. Now see, since Z equals to, first of all cancel out the common terms. We left with nu equals to Z square, that will be 4 RC into 1 by, again since the transition is taking in both the cases from 2 to 3, sorry from 3 to 2, so that means again we are going to use NF as 4 minus 1 upon, so this is 5 upon 36, and since you know that the value of 5 RC upon 36 is, 5 RC upon 36 is nu naught, and you also got this 5 RC upon 36, can you put the value of nu naught over here? So you got nu equals to 4 into nu naught as your relation. So let us just verify whether we are correct or not. So nu equals to 4 nu naught, that means option number B is the correct answer for the question. Okay. I hope you understood the question. Now let us just move to the last question of the session, question number 10. The question number 10 says, suppose the potential energy, please don't go over the length of question, it is a very easy question. It is just given to you to make you confused or to make you hyper about the question. Suppose the potential energy between electron and proton at separation r is given by U equals to K log r, where K is a constant. For such a hypothetical hydrogen atom, calculate the radius of nth orbit and its energy level respectively. So firstly, we have been given the potential energy, and what we are going to do, we have to find out the radius and the kinetic energy. So radius we have to find out, energy we have to find out. We have been given the potential energy, which is K log r. Again the question, as we have done in the very first question, the same thing we are going to use, du by dr equals to minus K upon r. Because this is the conservative force, du by dr is the conservative force, which is K log r. The differential of 1 by r is, log r is 1 by r. So it is du by dr equals to minus K by r. Now this is the conservative force, and we know that if the electron is rotating, there will be a centripetal force, which will be mv square by r, it is equals to minus K by r. From here I will be having the value of, let us just do one thing, we should take the magnitude of this force. So I am removing the negative sign so that I may not be getting confused with any such term. So it will be K by m. So V is coming out to be equals to under root K by m. This has came out to be my velocity. I have to find out the radius. I will do one thing, that I will be using the Bohr's quantization condition for the angular momentum, which says that mvr equals to nh upon 2 pi, isn't it? Since I have to find out the radius, this I have to find out, and I know the value of v, velocity, I will be putting this v over here and I will be finding out the value of r. So let us just do that. R will be equals to nh upon 2 pi, 2 pi m into v. So now let us just put the value of v, 2 pi m. V is equals to under root K by m. So this will be m upon K, isn't it? So you can use one thing, if you will be multiplying under root m in the denominator and numerator both, so you will be having under root m under root K. Finally what you will get, nhm upon 2 pi m into under root mk. To just combine these two terms, so m cancel, you are now left with radius equals to nh upon 2 pi under root m into k. Let us just check whether this radius is present, available or not. R equals to nh upon 2 pi under root mk. This is the correct. Otherwise on all these options you cannot see that this is the radius. So basically we can just tick over the option if you are not having time. You can see that if one option is correct and this is not available in the other option, that means this option, this energy must be correct. But we just are going to verify it once that this is the energy that is coming out to be true or not. So let's just do for the energy. This was for radius. Now since energy is, total energy is kinetic energy plus potential energy, right? Kinetic energy is half mv square, potential energy is k log r. V has came out to be equals to under root k by m that I have just removed. So that will be under root k by m square, or you can directly use k by m. So half m into k by m. So you will be left with k by 2 only plus k log r. Now r is nh, r we have just find out, nh upon 2 pi under root into mk, right? So since in the options I can see k by 2, k by 4, k by 3 has been taken out to be common. So from here I can see if I will be multiplying 2, multiply by 2 in both the numerator and denominator, I will be having k by 2 plus 1 by 2 k log nh upon 2 pi under root mk. So you can take k by 2 as common, you will be having 1 plus k by 2 is taken common, so you will be having 1 plus 2 log nh upon 2 pi under root mk, right? Now you can do one thing, if this is in multiplication and this is before the log term, it can be taken as the exponential form. So you will be having k by 2, remove this, you will be having k by 2, 1 plus log and the square of this complete term which is nh upon 2 pi under root mk, the square of this term. So what you will be having, if you can open the square, you will be having 1 plus log n square h square upon 4 pi under root 4 pi square into mp. Now let's just verify whether this is present in option number 1 or not. So 1 k by 2 common, 1 plus log n square h square 4 pi square mk, and this is the correct answer. If you would have seen that this is the correct, you can directly take over the option number A, but just to show you, I have completed my part from my end. I have taught you this 10 question. It is not mandatory that the question will be coming from this particular pattern. Question are, yes, this is the previous year question and the sample paper question which have been prepared, and I hope you all have understood this question and you all must be practicing more and more number of questions. So keep practicing, take care, thanks a lot.